Hi guys, so today we're going to be learning about parallelograms. So there's several properties of parallelograms and stuff like that, so we're going to start with that before getting to any of our examples. Okay. So a parallelogram is a type of quadrilateral where both pairs of opposite sides are parallel. So here we see that AB is parallel to DC and AD is parallel to BC. Then we have some properties of a parallelogram. So first of all, the opposite sides of a parallelogram are congruent. So here we see that AB is going to be congruent to DC and AD is congruent to BC. We also know that opposite angles in a parallelogram are congruent. So angle A here is congruent to angle C and angle B is congruent to angle D. The consecutive angles in the parallelogram are supplementary. So again, consecutive meaning they're next to each other. So an example, A and B here are supplementary, they add up to 180. A and D here are supplementary, they add up to 180. DC, they're supplementary, add up to 180, and BC. And then also we know that if a parallelogram has one right angle, they all have to be right angles too. The reason why, because if it's going to be supplementary to this, if they're going to add up to 180, if this one's 90, this has to be 90 as well. And same goes for this. And then since opposite angles are congruent, since this one's 90, this one has to be as well. And so this one kind of combines these two previous ones. Another thing we know about parallelogram is that their diagonals bisect each other. So we looked at diagonals previously, but diagonals go from one vertex to a non-consecutive vertex. Right? So here our parallelogram has two diagonals and they bisect each other. So that's RQ is congruent to QT and SQ is congruent to QU. And then our last property is that each diagonal of a parallelogram separates the parallelogram into two congruent triangles. So triangle ACD here is congruent to triangle CAD. Okay, so with that in mind, we're going to get started with our first example, which is just proving one of these theorems. So we're going to write a two-column proof for opposite angles in a parallelogram are congruent. We're given this parallelogram to help us kind of explain things. And we want to prove that angle A and C are congruent and angle D and B are congruent. So I'm going to start with my statement and my reason column. So the first thing is my given, and my given is that I have a parallelogram known as ABCD. So that is given. Okay. And then because it's a parallelogram, I know that opposite sides of a parallelogram, I know that the opposite sides are parallel. So that means here that AB is parallel to DC. And I know that AD is parallel to BC. And I know that because that's the definition of a parallelogram. A parallelogram has two pairs of opposite sides that are parallel. Definition of parallelogram. So I'm also just going to label it my picture. So AB and DC are parallel, and AD and BC. Right? So these two are parallel, indicated by the one arrow, and then these two are parallel, indicated by the two arrows. Then, what I know is that angle A and angle D are supplementary. I know that angle D and angle C are supplementary, and I know that angle C and angle B are supplementary. So angle A and angle D are supplementary. I know that angle D and angle C are supplementary. And I know that angle C and angle B are supplementary. And the reason why I know that is because of consecutive side interior angles or same side interior angles. So consecutive side or same side interior angles theorem, right? They tell us that if angles are formed by parallel lines cut by a transversal, that they are supplementary. That's consecutive or same side interior angles there. Okay. Then, as a result, I know that angle A and angle C are congruent. And angle D and angle B are congruent. And the reason for that is because supplements of the same angles are congruent. Supplements of the same angle, right? So both A and C are supplementary to D, right? And then both D and B are supplementary to C. There you go. Okay, so why don't you check your progress 1. It would help to have this picture here to write a paragraph proof for this. Okay, so this is what you should have gotten. Okay, we know that MNPQ is a parallelogram and angle M is a right angle. So by definition of a parallelogram, then we know that MN is parallel to QP. Since angle M here is a right angle, that means that MQ and MN must be perpendicular. By the perpendicular transversal theorem, then, MQ also has to be perpendicular to QP, because if there are parallel lines and a transversal is perpendicular to one of them, it has to be perpendicular to the other one as well. Right? So that's why MQ is also perpendicular to QP, which means then that angle Q is a right angle because perpendicular lines form a right angle. Then we also know angle N and angle Q are congruent, and angle M and angle P are congruent because opposite angles in a parallelogram are congruent. So if they have to be congruent, and we already know that M and Q are right angles, that means angle P and angle N are right angles, since all right angles are congruent. And there you go. Okay, so now let's move on to example 2. So here we have quadrilateral LMNP. It's designed to be part of a new company logo. We want to find the measure of angle PLM. So we want to find what this is, this whole thing. We want to find out what LMN is, so this whole thing. And then we want to find what D is. Okay. So one thing we know about parallelograms is that opposite angles are congruent. So that means the measure of angle PLM is going to be the measure of angle PNM. So it's going to be congruent to this angle here. Okay. We know that PNM consists of this 42 and the 66. Which means then that PLM is 42 plus 66, which is 108. And so PLM is 108 degrees. Okay. Then, to find LMN, we know that consecutive angles for a parallelogram are supplementary. So what that means is that the measure of angle LMN plus the measure of either PLM here or PNM, that it should equal 180. Okay. We just found out that PLM is 108. So then we just need to subtract 108 on both sides to know that LMN is 72 degrees. Okay. And then the last one here, to find D, we know that parallelograms, opposite sides are congruent. So if this is 2D and this is 22, we know that LM should equal PN. LM is 2D. PN here is 22. Divide by 2 on both sides. D equals 11. And there you go. This used the idea that opposite angles of a parallelogram are congruent, consecutive angles of a parallelogram are supplementary, and opposite sides of a parallelogram are congruent. So why don't you try check your progress too, and then come check your answer when you're done. Okay, you should have gotten that MN is 15. If you got that, you can move on to our last example. If not, here's your explanation. Okay. So we know the perimeter of the parallelogram is 74 units. So perimeter, again, is to add up all the sides around. Okay. We also know that if it's a parallelogram, the opposite sides are congruent. So if this one's 22, this has to be 22 as well. And then these two have to be the same thing, which we don't know what it is. So that's why I marked it as X. Okay. So that's why 22 plus 22 plus X should equal 74, the perimeter. Combine like terms, that gives me 2x and 44 equals 74. Subtract 44 on both sides, 2x equals 30. Divide by 2 on both sides, x equals 15. So MN here is 15. Okay, now this is our last example. What are the coordinates of the intersection of the diagonals of parallelogram ABCD with vertices A25, B66, C40, and D0, -1? So I'm just going to do a little brief sketch really quickly. So A is at 25, so 1, 2, 1, 2, 3, 4, 5. So here's A. B is 6, 6, 1, 2, 3, 4, 5, 6. So this is already 5, so 1 more. So B is here. C is at 4, 0. And D is at 0, -1. So it doesn't quite look very good, but it's okay. Okay, so we want to know what the coordinates of the intersection of the diagonals are. And so what we know about the diagonals is that they bisect each other. Right? So what I'm going to do, I didn't write a little. Let's see, this is D. So what I'm going to do is I'm going to find the midpoint, okay, because the intersection is the midpoint. Right? So then I'm going to find either the middle of AC or the middle of BD, it doesn't matter. So midpoint of AC. So that will be 2 plus 4 divided by 2. And then 5 plus 0 divided by 2, which this gives me 6 over 2 and 5 over 2, which is 3 and 2.5. Okay, so that means since the intersections bisect each other, the midpoint has to be at 3, 2.5, which is D. Okay, so why don't you try CYP3 on your own, and then once you're done, come check your answer. Okay, you should have gotten F. You should have either been finding the midpoint of RT or SU that would give you the same point because they bisect each other. That's where they intersect. So that's it for today. Have a great rest of the day. Bye, guys.